Winds are pretty neat winds. These winds come off of glacial environments, so think Antarctica as the diagram in the slide suggests. Think Greenland, think Patagonia, which is at the very tip of South America. Large volumes of glacial ice that are adjacent to a body of water. Now we know that with ice, it's light in color, so it has a high albedo, so it's radiating lots of energy. It's not absorbing any energy, so it's not generating any heat. So these are perpetually cold environments. Because they're perpetually cold, they're going to be high in pressure, and so the wind is going to move off of these ice masses onto an adjacent ocean. And because water is always going to give off some volume of heat energy that it has collected, the ocean mass adjacent to the ice mass is always going to be warmer than the ice mass. Therefore, there's going to be a perpetual low pressure cell sitting over the ocean. So the wind is going to move off of this land and ice mass onto the ocean adjacent to it. We've got two other really important characteristics that we need to consider here. And one is that we've got some gravity happening. So ice, we don't often think of ice as being really tall, but it's got a large vertical face to it. So these winds drain downward, being pulled by gravity, and gravity accentuates, it accelerates the rate of descent. So these winds become rather fast. The other thing that's happening is that Iceland and Greenland and, Greenland and Antarctica, not Iceland. Iceland doesn't have that much ice. Greenland and Antarctica and Patagonia are large areas of ice, and the water bodies next to them are rather large. So that means the pressure gradient between these features is rather significant, which means the pressure gradient force is significant, which means the winds are going to be really fast. So kadiabatic winds are consequentially some of the fastest winds in the world, which means they're really quite dangerous winds.